Can everybody hear me? Okay, I'm mic'd up okay. Well, thank you very much. I very much enjoy being here, and this was a special event this year, of course, by the change of having awards presented to everybody in a venue like this. I want to start by talking just a little bit about something that this industry is supporting us in a very important endeavor, and that is the 11th International Terroir Congress is coming to Oregon this summer. We've been planning this for about 2 years now. We have scientists from all over the world who study aspects of geology, climate, plant systems, soil, even terroir tourism coming to see Oregon. Currently, we have scientists from 23 different countries, many who have never been to the state of Oregon before. So this will be a discovery for them, and I think an exposure for us as a viticulture area in the scientific community. So you may be hearing from me over the next few months in terms of this endeavor, but if you can help out at all, promote it, please do. You want to get involved, let me know. I'm going to be giving a talk like I've done in years past. I very much enjoy doing this. It's something I think I've been doing since 1997 in prior iterations of this meeting. We'll talk a little bit about what we've been seeing in the past and the present and the future. But first, I wanted to put up a diagram here, a map of sea surface temperatures out in the Pacific. I've talked about this before. You've seen many of these kind of things in the media talking about the importance of the Pacific Ocean temperatures to our climate here in the western United States. The media has certainly touted up kind of the characteristics of what this winter was supposed to be. And I've even been contacted by Hollywood looking to do a movie about the Blob, the Son of Blob, and Godzilla. Now, come on. I got a good laugh right here from a climate geek, Robert Britton, but very few other people. Okay. There is something very important here that's going on, and I think that we need to talk just a little bit about it, and I'll give you some background to that. But I need to move into kind of what we're going to talk about here. I'm going to talk a little bit about kind of where we've been, climate-wise, from a global perspective. A little bit of this was in yesterday's session as well. We'll talk a little bit about what Oregon experienced, because when we talk about what we just experienced, we can better understand what's happening out there both today and maybe into next growing season. And then we'll look at what our conditions are right now, and what does that foretell for the coming few weeks to few months to the rest of the season. So if we do a global summary, I think everybody has seen a couple of these diagrams. This is 2015 global climate data, spatially mapped out, and then also in a time series. We know that 2015 was the warmest year since 1980, 1.6 degrees Fahrenheit over the average. And interestingly, it beat the record in 2014 by almost 1/3 of a degree. That typically doesn't happen when you look at these kind of climate records. The United States ended up having its second warmest year on average total. We'll talk a little bit more about that here in just a minute. And then continued ocean warming, both globally and regionally, has contributed to this. And the strong El Niño we've been having, I think, will contribute again to what we'll probably see in 2016. If you look at just the United States, this is just some data ranking how each state experienced temperatures during the 2015 year. And the numbers here, 121 means it was the warmest ever in terms of temperatures. These are averages, and you can see the center part of the United States going up through Texas and the Ohio River Valley was a little bit cooler than everywhere else, but still everyone was still much warmer than average. We can look at the continental United States and say that we were about 2.4 degrees Fahrenheit above normal, second warmest in that record, and also the 19th consecutive above average. If you break this down, though, I think it's worth noting that if you look at just maximum temperatures, you can see a little bit different kind of pattern. The structure is still there, but the Pacific Northwest really saw the extremes in maximum temperatures much more so than the rest of the country, especially in Texas where rainfall was important. We'll see that here in just a minute as well. But when you go to minimum temperatures, I think this is where the big one shows out. I know I've been talking about this for quite a few years. I think our ocean temperatures offshore show us this, that when it's really warm, we end up having warmer nights, and the entire western United States was that way. California was off by 1, but it was pretty darn close. And you can see that even parts of the southeast was off, or was on a record characteristic as well. If we go to precipitation, the country was a little bit mixed overall. We were very wet in Texas and Oklahoma and parts of the center part of the United States, and very dry in California, and then lo and behold, really dry in Connecticut, Rhode Island, and Massachusetts. If you look at the United States as a whole, our continental United States, if you averaged it up, was 4.5 inches above normal in terms of rainfall. Kind of hard to tell that to people in California. It ended up being the 3rd wettest year that we saw as a country as a whole, and our drought footprint actually shrank last year. And we'll look a little bit more about kind of where the drought characteristics are and what that is showing for the coming year. We also have a set of data that colleagues, I was on a committee years ago looking at developing this index, trying to have a measure so we could say, how do we compare one year to another in terms of extremes? And so we were looking at characteristics of extreme maximum temperatures, extreme minimum temperatures, one-day rainfall, hail, wind events, those kind of things. And we came up with an index which encompasses all that. And you can see what we have here for both a time series and then overall for 2015, that we were either much above average or at its highest level ever. And much of the United States has seen more extremes than we've seen at least in the past 100-year record here. If you look at the numbers, the United States as a whole last year saw more records in maximum temperatures and minimum temperatures, but not on the low end, on the high end. So we're seeing more records at high minimum temperatures and more records with one-day precipitation totals, not necessarily in the west, but more appropriately in the east and southeast. The Northwest and the West had elevated extremes, of course, in maximum temperatures and minimum temperatures, but also the spatial extent of drought last year was about at its largest level ever. The Northwest had its highest index value on record, and the West had its second highest. Breaking it down, getting into Oregon again, and talking a little bit about what we experienced, this diagram looks at monthly values for temperatures departing from normal. Anything going above the 0 line is warmer than normal, and it goes from November of 2014 through October of 2015, and then we have some seasonal information on the far right. But if you look at this, you can just see how far monthly temperatures departed in our main wine-growing regions in the western, or in Oregon. Roseburg, Medford, McMinnville, Milton-Freewater. The one blip that you can see in November is in Milton-Freewater in the eastern Oregon, eastern Washington. This was the big event last winter that produced moderate damage from place to place depending on kind of location and variety. But if you can look at the overall characteristics there, there's quite a few things going on. One of them I want to highlight, and we'll see it in a couple of other things here in a minute, is September. We ended up having a fairly normal September, and I think this was a real key to last year ending on such a high note overall. If you look at the numbers overall, the dormant season was 3.6 to 4.5 degrees above normal. That's almost unheard of for a winter, almost anywhere. Our growing season was 3.6 to 4.2 degrees above normal. The Willamette Valley was right around 4, pretty much everywhere in this region. We can go to precipitation and kind of look at the same thing. I know the diagram looks very different. It's because of the extreme deficits that are over in the seasonal column on the right, but going again from November 2014 through October 2015. What we're seeing here is of course, the experience that we had, a very dry winter. The only above normal blip there is Milton-Freewater in December was a little wetter than average. But a couple of things to highlight in here that I think are really important. The rainfall that we got in February may have been the most critical rainfall we've seen in a few years because it really helped us get into the season and probably gave us just enough soil moisture to get the vegetative period off on the right order. Overall, though, we had 30 to almost 60% down in terms of winter rainfall last year, and then the growing season, which we don't get much anyway, But if you take very little and you reduce it by up to 70%, you're in trouble. So we did have a dry year last year, although it wasn't as dry as the year before, so it was very fortunate. This is another one of those diagrams I use a lot. I have these for all over the state, and this one's just for McMinnville to kind of tag into where we are here now. And you got precipitation in the blue bars on the axis on the left-hand side. On the right-hand side is average temperature departures. So this is going positive and negative, with the gray lines being day-to-day and the black line being kind of a weekly moving average. A lot of different things we can talk about in here. You can even see in the Willamette Valley the cold period. The coldest period of the winter happened in November. It was the same event that impacted eastern Oregon and eastern Washington. We just didn't get as cold here. We just really didn't have much cold weather throughout the winter at all. Again, there's that big burst of February rainfall that I think was very important. You can see the warmth during the summer. One thing that doesn't show up in here that is worth noting is August, the cool down at the end of July and early August. There's some preliminary data that says that the smoke from the fires this past summer may be largely responsible for that. And basically, we've been looking at places that had no smoke versus smoke, and it was about a 1.5 to 2 degree reduction in maximum temperatures in those locations. So smoke may have had a play in that. But again, you can see the September cool down, which I think also was very critical. You can look at our growing season, again, almost 4 degrees Fahrenheit above normal. Rainfall was down in the valley up here. And then if you look at the phenology, and this comes from people that I talk to in the industry, if you look at the basic growth cycle, one of the earliest growth periods we've had in terms of bud break, bloom, veraison, and then harvest. Many people who've been here quite a long time said it was the earliest harvest that they've ever seen, but also people were feeling very unpressured to bring fruit in, so it was a nice kind of a long, drawn-out period for harvest. If you look at growing degree days for each one of these locations, I've shown this before, and I think there's a couple of things to note here. Number one, McMinnville acted like Roseburg does historically in terms of temperature values, almost identical overall, while Roseburg was much warmer than what we would normally see in any given year over the past decade or so in the Medford and or Milton Freewater area. These numbers were just slightly down from 2014 to a little bit above, so they were pretty close to what we were calling for last year, remaining quite a bit above either our last kind of decadal average and or our 30-year average in terms of heat accumulation. So just to summarize this into some verbiage to kind of tie it in together, extremely warm winter. There's absolutely no doubt. You guys all experienced this. We're having a similar winter right now, not quite as warm as it was last year. This little cool down that we've just had has been very important, I think. We had an overall very dry winter also last year, but February rains, I think, were very critical. November, minimum temperatures were problematic on the east side, definitely moderate to some pretty heavy damage in places. Spring continued very warm and dry. There were some isolated frost pressure, but it was very limited in 2015. We'll talk a little bit about that for 2016 in a moment, too. We can also go to looking at aspects of maximum and minimum temperatures. We broke more records in Oregon and most of the Pacific Northwest in 2015 than in any of the past 30 years that I could find data on. Heat accumulation was on par with 2014 or at record maximums, depending on which location you were at. And this smoke in August was something that I think is kind of interesting relative to maybe keeping us even below what we could have been otherwise in a record year. And this cool down, I think, was really important in September that really helped us ushered in a very paced harvest. If you look at growing characteristics from what people have submitted to me, 2 to 4 weeks ahead of normal for bud break. I even heard somebody mention that they were in some varieties 5 weeks ahead for their location. Bloom continued that trend very early, very little rain. Most people said that it was a very rapid, very clean, very heavy fruit set that came from that period. Veraison continued that same cycle, running up to 4 weeks early, typically carrying a large crop statewide. And harvest was likely the earliest on record again, and no rain pressure that was dramatic enough to really force the hand at harvest. If we look at just general numbers from composition, this is statewide from people I've talked to. Brix levels were mostly up, small amounts from place to place, but up mostly statewide. Acidity levels were just slightly down. pH levels were slightly up. And yields overall, from everything that I can see from people talking to me about this, are about 10 to 20% up. They're lower in areas that were impacted by that freeze and winter damage in 2014. But in contrast to Washington, which I think just came out with numbers where they were roughly about 2% down, and California, which is probably anywhere from 3 to 7% down, we ended up being in quite the sweet spot in terms of a fairly good vintage in terms of volume and also quality from what I heard from others. So where does that take us to current conditions and kind of what's going on out there right now? I posed the question of a typical El Nino winter. I talked to Kevin Chambers earlier, and we talked about how untypical it was. If you look at what we expect when we have an El Nino set up in the tropical Pacific, we typically get something that looks like this, where it's typically wet to the south, the flow, the jet stream splits a little bit, we have a mild northern tier, wetter up into Alaska and British Columbia, and we tend to be fairly dry in this area. And if you look at the basic pattern here, we would typically have this kind of situation. Everything from the Oregon-California border north would be warm and dry, everything south would be warm and wet, and this is that little transition layer area where it just moves a little north and south depending on the El Nino kind of form and function. This has not really occurred this year. It's been very, very abnormal. And there's probably a lot of things tied into this. I can tell you that one of them is that our ocean temperatures, that blob and sonoblob, so on and so forth, we have never had an El Nino year where we've had really warm tropical waters at the same time we had as warm of North Pacific waters as we've had. And so I think that they kind of washed each other out in some ways. They produced a situation in the Pacific Northwest which was completely what we wouldn't have expected. The temperature patterns have changed a little bit in the North Pacific, not dramatically enough for me to say much about that altering things, but in the tropics, we're already seeing El Nino on its way out the door. And we'll talk a little bit more about that in a minute. So temperature patterns, this is from the first of the water year through just the other day. Temperatures are not completely following what we expect a normal El Nino winter to be. We would normally expect it to be a little bit warmer in the Pacific Northwest, much warmer in the California desert Southwest and into the Great Basin. And we've seen areas that have been much colder than average in the Great Basin. So it's just really hasn't been quite what we expected. But you can see in places in Oregon, we've still been 2 to 4 to 6 degrees above average in terms of temperatures. Precipitation has been all over the board. We would typically see an extremely dry winter in the Pacific Northwest, and we've seen almost the opposite. Portland, of course, has just announced its wettest December through February record at this point, and there will probably be others that will announce the same thing coming soon. But if you look south, where we would expect the El Nino effect to have much greater rainfall into Southern California, even into the Bay Area, it just hasn't materialized. It's been quite spotty. And I just think we have a lot of dynamics that are going on that are causing this. It's better than it's been for the past 4 winters, but it's still not what everybody expected. If you look at snow water potential or snow water equivalent in the mountains, this is over the western United States. I'll show you Oregon in just a minute. It's much better than we would have expected, especially looking back to last year. But you can look down in the Arizona and even into New Mexico, it's quite low there. Again, we wouldn't have expected that. Here we are in Oregon right now. The most recent numbers are showing us that we're at least 100% or close to it, with the exception of the Willamette Valley watershed area has just recently dropped just because there hasn't been much snow input over the past few weeks. I would expect this to go back up a little bit. But if you couple this with what it looked like last year, that's what we were talking about when I was standing up here last time, talking about having almost no water in the mountains, and at least now we have some to count on. If you look at the US Drought Monitor, this again is the most recent data that they have out there. It's not telling very much about the broader pattern in the United States, but we are at a place where the drought footprint has shrunk pretty much everywhere except the West. If you isolate this just on the western United States, you can see large areas of California that are still in exceptional drought. But there's also, if you look at those two red boxes on the far right-hand side, we have seen reductions of 20–30% of areas that have been in at least moderate to severe drought, and especially in western Oregon, western Washington, and even moving over into eastern Oregon and eastern Washington. So we have seen some drought reductions, and likely to see a few more, and we'll see some other evidence of that here in just a moment. So as we look at 2016, here we are in February trying to figure out what to do coming up with this vintage. There are some things out there that we can kind of go on. If we look at some of the baseline data that NOAA puts out, the March, April, May forecasts that are out right now, the 90-day forecasts, indicate that we have a much greater likelihood across the Pacific Northwest and northern tier of states to be above normal in terms of temperatures. It doesn't mean that we're not going to have any cold air. It's just that it's more likely that we're going to be warmer than normal over the next 90 days than we will be cooler. This probability holds when you move into continuous 90-day periods as you move out into the summer. If you look at rainfall characteristics, rainfall from March, April, May is indicating an increased likelihood of being wet south. And this is kind of that typical, we would expect the desert Southwest and Southern California to be wetter as El Niño kind of moves its way out, while we would expect to be drier. The EC means that the forecast doesn't have anything telling us that we're going to go either direction, so it's likely to be pretty normal overall. So if you look at the seasonal drought outlook from the Drought Monitor, again, you can see that broad pattern in California in the kind of taupe color there, where drought remains, but it improves. That's, again, looking at the forecast saying there's going to be at least some input throughout the rest of the rainfall period before we move into summer. But the brown area, especially through Northern California and up into Idaho, eastern Oregon, eastern Washington, these are areas of which they think that the drought will persist just because of seasonality of rainfall availability. So a broad summary, there's continued warming out there globally as a whole. I think the dynamics of our climate system is telling us quite a bit. The persistence of that climate system is telling us a lot in terms of how ocean and atmosphere is coupling. And I don't see any reason why the trends we've seen over the past few years aren't going to continue for 2016. Extremes have gone up in severity and in frequency, especially in the western United States. The NOAA release just recently is saying that that's likely to continue this coming year. Likely more heat stress events is probably the key number that they're looking at right now, while spatial extent of drought will likely go down. The effects of El Niño have been occurring mostly as expected everywhere else, but here. Indonesia, Philippines, Australia, New Zealand, El Niño's been doing about what we expected. Same thing in South America, in Argentina, Brazil, Chile, even in Texas and into Florida. But very little in terms of western United States has been normal in terms of this El Niño winter. And again, I think that there were some things going on between the North Pacific and the tropical Pacific that caused them to kind of cancel each other out in some ways. These El Niño influences have been hit or miss of late. There's still time. I don't see it as being a big hit over the next few months of the rainy season, but places in Southern California into the desert Southwest and Texas will probably be seeing more than we will. And all evidence is pointing us to El Niño conditions starting to wane for this next coming year, and that kind of ties into the last slide here, or the last two slides. These tropical sea surface temperatures are declining right now. They're transitioning to what we call neutral. We can talk about that as we kind of move into next year. However, there is some evidence that we could flip almost immediately into a La Niña, and that means something completely different. The last large La Niña that we saw was 2010. Doesn't mean that our growing season is going to be like that because we have to look at a bunch of other things happening together, but we need to keep an eye on this in terms of 2017 vintage and beyond. The North Pacific has cooled a little bit, but it remains warmer than normal. It doesn't transition quite as fast as the tropics do. Therefore, I think we're still going to have warmer ocean temperatures offshore this coming year. All of these kind of conditions will tilt the odds to Oregon and the Pacific Northwest, having a warmer and drier late winter, early spring. California will likely be warm and wet late winter, early spring. If you look back at history, spring frost frequency during these type of years tends to be much less, but heat extremes during the summer tend to be higher. So you're giving one for the other. Potential for continued drought relief exists, and I think there'll be moderate recovery, but there are some places that probably just won't get enough between now and the end of the rain season, snow season before things start going down. If we look at everything we know from how we build our dynamic models of the atmosphere and ocean, in terms of what it's telling us, look at historical analogs of similar years and similar conditions, and if we look at persistence, just the logic that persistence tends to carry itself through from year to year, I think it really points to us having, again, another fairly warm growing season, higher heat accumulation than normal, and somewhere between 2012 and 2015. I think last year we were talking about us being really close to 2014. It bore out, and I think we're going to be pretty close to this period of years as well again. Well, with that, I appreciate it very much. Thank you for having me here.